Alright, hi, my name is Jillian Ellisberg. I'm going to be doing some practice one-dimensional kinematic problems today. So I have three key equations written up here. Ignore all this stuff for now. Sorry. Okay, so the first equation is VF equals VI plus AT. Okay, so I'm just going to define the variables really quick. VF is final velocity, VI is initial velocity, A is acceleration, and T is time. So it is final velocity equals initial velocity plus acceleration times time. Okay, moving on to the second one. XF is final position, XI is initial position. We just defined VI, T, A, and T. So final position equals initial position plus initial velocity times time plus 1/2 times the product of acceleration times squared. Okay, moving on to the third one. We just defined VF and VI and A, so the only one you have to define is V, which is displacement, which has to do with XF and XI, which is final and initial position. So this one is final velocity squared minus initial velocity squared is equal to 2 times the product of acceleration and displacement. Okay, so I'm going to start working on the first problem, which is why I have stuff written out over here. Okay, so the problem is a jalopy travels on a long straight level road at 50 kilometers per hour and then speeds up to 90 kilometers per hour in 15 seconds. Calculate the jalopy's acceleration in meters per second per second. Okay, so here I'm just doing a calculation to find what it would equal in meters per second, or the velocities are equal to in meters per second, because in the problem they are given in kilometers per hour. So we need to fix that. So that's what I'm doing here. I am multiplying through to get hours into, or to convert hours into seconds. And then over here I'm converting kilometers to meter. So in the end, when I convert 50 kilometers per hour to meters per second, I will get 25. Okay, and we'll remember that the final velocity is what I just solved for, because that was 90 kilometers per hour. So I'm going to start filling in this table which I've made for myself, which makes the one-dimensional kinematics problems like way simpler. So I'm going to just start filling it in because, I don't know, it's nice to know what variables you know and which ones you don't know and not have it just all in your head. So VF is now 25 meters per second. Okay, that looks like an 8. Sorry. Okay, so now I'm going to just kind of go back to this equation, and instead of a 9 here, I'm going to put a 5 because that was the initial velocity. Okay, and then I'm just going to multiply through again, and I will get 50,000 divided by 3,600 is equal to about, we're just going to round, 14 meters per second. I'm doing this on my calculator. It's pretty, it has stars. Okay. So the next thing I'm going to do is start filling in what other variables we have. So you'll remember that in the problem, here, I'll show it to you guys again. It's that first one. Yeah. Okay, well you can pause it if you want to see it, but our time is 15 seconds. I'll just put S, this is ridiculous. Okay, and we know that we don't really need to know the positions, because we can use one of our key equations with what information we already have. So we have VF, we have VI, we have time, and we're trying to find acceleration. So I'm going to use this first key equation to solve this problem. It's pretty simple. So I'm going to do VF equals VI plus AT, which is 25 equals 14 plus A times 15. Okay, so this will be 9 equals 15A, A equals 9 over 15. Cool. Oh wait, meters per second. Okay, so we just found the answer, because we were supposed to be finding the jalopy's acceleration in meters per second. So, yeah.